Okay, page 2 of our review. Let's continue on. Solve by taking the square roots. I can take the square roots if I can get something squared on one side of the equation. So in this particular case, I can write 3x squared equals negative 28 plus 7. So 3x squared equals, so if I take this, it's what, negative 21. If I divide both sides of this equation by 3, I get x squared equal negative 7. Now I'm ready to take the square root of both sides. And then what that gives me is, on the left, square root of x squared, I get x equal plus or minus square root of negative 7. The square root of negative 7, so this is x equal plus or minus I times the square root of 7. So x is plus or minus I square root of 7. Next equation. Isolate something squared on one side. You have a Christmas gift early. You've already got that. X minus 2 is squared. So if I take the square root of both sides of this equation, so x minus 2 squared equals 16, take the square root of that. On the left, you just get x minus 2 equal plus or minus square root of 16. So x minus 2 equal plus or minus 4. X equal 2 plus or minus 4. So x is equal to 2 plus 4 is 6. 2 minus 4 is negative 2. So your two answers for this guy are x equals 6 or x equal negative 2. Then we have some questions about the discriminant. So in this case, let's find the discriminant. So b squared minus 4ac. So that is going to be 20 squared minus 4 times 4 times 25. So that's 400 minus 4 times 25 is 100. 100 times 4 is 400. This is 400 minus 400. So b squared minus 4ac is 0. So when the discriminant is 0, I will get one solution. That solution will be real and it will be rational. Okay, let's look at the next one. B squared minus 4ac, that's negative 2 squared minus 4 times 1 times negative 2. So that's 4 plus 8, which is 12. So I'm going to have to end up solving this to take the square root of 12. So the square root of 12 is not a perfect square. I will get two. The solutions will be real, but they will be irrational because I'm going to have a square root of 12 in my answer, and that's going to leave me with a radical that simplifies down to 2 square root of 3. The next one here, value of the discriminant. So it's b squared. So 2 squared minus 4 times 1 times negative 3. So that's going to be 4 plus 12, which is 16. That's a perfect square. So when I take the square root of 16, I will get 4. So my answer is going to have a plus or minus 4. So I'm going to have two answers. They will be real, but they will be rational because there will be no square roots in my final answer. The next one here, if I look at this, b squared, so that's 2 squared minus 4 times 1 times 5. So this is 4 minus 20, which is minus 16. So when I take the square root of minus 16, I'll have plus or minus square root of minus 16. I will get two answers. And so I'll get two answers, and they will be complex numbers. Okay, so that's just properties of the discriminant. Let's move on. I'll do the next page while I'm here. Solve by any method. So you get to decide which method. This method is just begging you to solve by taking square roots because you've got something squared on both sides. So if I take the square root of both sides of this equation, I will get x minus 4 equal plus or minus the square root of 17. So x is equal to 4 plus or minus square root 17. That's my answer there. So this one, what do I want to do? So I have to think, well, can I factor this? Are there numbers that multiply to -2 and add to 1? So it looks like if I had a 2 and a -1, those multiply to 2 and add to -1. So in this case, there are the numbers that multiply to -2 and add to +1 would be this. Multiply those, you get a -2, add them, you get 1. So this will factor as x plus 2 times x minus 1 equals 0. So x is equal to -2 or +1. Now, if you did not factor that, you could use quadratic formula. So in this case, I know that b squared minus 4ac, that is equal to 1 squared minus 4 times 1 times -2. So that is 1 plus 8, which is 9. So the quadratic formula is x equal -b, that's -1, plus or minus the square root of 9, all of that over 2a, which is 2 times 1. So this is just -1 plus or minus 3 over 2. So -1 plus 3, that's going to be 2. So 2 over 2 is 1. -1 minus 3 is -4. -4 divided by 2 is -2. So without too much work, you can get to the correct answer both ways on that one. Let's look at this one. Let's just figure out another strategy is to always look at these and say, let's figure out b squared minus 4ac and then figure out what to do. So that's going to be 1 squared minus 4 times 1 times 1. So that's 1 minus 4, which is -3. The discriminant is negative. I'm going to have a square root of -3. Complex numbers, I'm not factoring. So this has to be quadratic formula. So x is going to be -b plus or minus the square root of b squared minus 4ac, all of that over 2a. So x is -1 plus or minus b squared minus 4ac is a, so that's -3 over 2a, which is just 1, which is 2. So this is x equal -1 plus or minus I square root of 3 over 2. So you could leave your answer like that, or you could write x equal -1/2 plus I square root of 3 over 2, plus or minus. Either of those would be good answers for that problem. So again, in this one, sometimes, like in this one where I get complex solutions, the only way to solve that is quadratic formula. The one in the middle, you saw me do quadratic formula or graphing. The first one, you should just know that square roots is the quickest way of doing that. You don't want to FOIL that out on the first one, part A, and then do quadratic formula. That's way too much work on that one. So if you can see square roots, that's obviously the shortcut for that one. So let's take a look at this guy. 6x squared plus 11x plus 3 equals 0. So to factor, I've got to ask myself, I could figure out the discriminant and go from there, or I could say, let me just try factoring, see if it works. If I don't get anywhere, then go to quadratic formula. So if this factors, I would need to find two numbers that multiply to give me 6 times 3, which is 18, and add to give me 11. Are there numbers that multiply to 18 and add to 11? Well, 2 and 9 are those numbers. Double check them. 9 times 2 is 18, 9 plus 2 is 11. So this will factor. So I'm guaranteed it will factor if I write it like this. 2x plus 9x plus 3 equals 0. Then I factor by grouping. I look at those two and I look at these two. The first two terms have a 2x in common, so that leaves me with 3x plus 1. And if I've done this right, I should get a 3x plus 1 in the next term. Factor out a 3, and I'm left with 3x plus 1 equals 0. So this is 2x plus 3 times 3x plus 1 equals 0. Set each factor equal to 0. So 2x equal -3, x equals -3 halves. That's one solution. 3x plus 1 equals 0. 3x equal -1. X equal -1/3. That is the second solution. So I've solved this particular one by factoring, and that is the end of the review.